Hi guys, my name is Ian, and this week it's lesson number 9 in Paul McWhorter's Arduino with Python series. This week we had to basically make a nice humidity meter for the DHT11. Now, I did that last week, so we'll have another look at that meter. Additionally, I've done other things. Paul was talking about sending data to the Arduino, so I started thinking of LEDs, so I've got some LEDs to show you as well. Let's have a look at my hardware first. Here we have it. My trusty Arduino Nano. Mr. Blue is the DHT11. Mr. White is the DHT22, and there is the potentiometer. The circuit and the code have not changed for the past 2 weeks. So we will just have a quick look at the code just for completeness. And here we have it. It is a simple millis driven loop. Inside the millis loop we have various jobs that run on different cycles, basically getting the potentiometer reading 10 times a second, whereas the DHT11 reading is only once a second, and the DHT22 is only once every 2 seconds. The millis takes care of that, and then at the end of all of that good work, it sends out a comma separated list of variables out the serial port for the Python code to catch. So if you want to know how this code works in more detail, hark back to lesson number 7 where I explain it a bit more, or pop a question down below. I'm happy to answer any questions. Anyway, we spoke of Python. Let's have a quick look at the Python. That's been where all the fun has been this week. So what are we looking at here? Oh my goodness, we're looking at a small LED. That was the first thing I did this week. I made myself an LED. Now this is just a typical looking LED. It's got a dome, a body, a base, and it's even got a couple of legs sticking out the bottom. And when you update it, you change its color from the default. The default in my case, I like grey, so mine when they're off are a grey color. And when they switch on whatever color I decide to set them on to whenever I do the update. So that's just one LED. What can be better than one LED? Well, how about 3 of them in a blue, green, red bank? And that's exactly what this is. We're looking at them. They can be in a row or in a column. I've used them in a column. I'll show you that later. But the main point here is, why have I got 3 of them? Well, my idea was that I could have 3 LEDs to indicate the temperature at different bands. So if it's too cold for me, it's blue. If it's just right, it's green. And if it's too hot for Ian, it would be red. I've set the thresholds here. Anything below 5 is too cold for Ian, and anything above 30 is too hot for Ian. So that's what we have there. We basically draw 3 LEDs in a row or in a column as per what we want, and then in the update we turn them on as per what the thresholds are, and if they need to be off, they're left off. Simple as. This is what it's doing here. It's if it's under the threshold, that's what this measurement's about, and when you update it with nothing, it just puts it to the default, which in my case is the grey. So that's switching it off. So when we're in the blue band, it turns the blue LED blue and turns the other 2 off. And similarly, when we're in the green band, it turns the blue and the red off and turns the green on. And likewise, when it's too hot for Ian, the red one gets switched on. So that's 3 LEDs in a column. You'll see those in a moment. The other fun this week was in my standard meters. Now, I've mentioned the humidity meter. That's what Paul wanted us to write this week. I had one from last week. Unfortunately, my one from last week had a bug in it, and once I realized the bug, after my shock and embarrassment at myself, I actually decided to fix it. So what was this bug? Well, it's the classic bug. I wrote the code assuming things like zeros and hundreds, and that's all well and good, except when you hard code them into the updates, and then you might start. So if we look at last week's code, you'll see whenever I'm working out what meter segments to turn on, I'm working through my meter segment list, and I'm starting at the scale min, which is absolutely fine if scale min happens to be 0, but a complete disaster if it's anything other than 0. So what did I do in the fix? Well, I took away all that reference stuff to hard-coded values, whether they happen to have been passed over or not. The assumptions were the killer. So what I've done is I've now worked out how many of the LEDs need to be on in this. This is the round, if you think the round circular scale, it's actually 101 segments. So I work out the proportion that need to be on. So if you imagine you're halfway through your range, that's 50%. That's what this is working out. That's what it's trying to work out. And then it goes through all the LEDs, switching them on or off as need be. And if it's fully on, the opacity is set to 1. If it needs to be partially on, if we're sort of a fraction of an LED, it sets it to the proportion. Actually, there's it set in it there. It's using some rather interesting modulo maths. The modulus 1 of anything returns the fraction. So if I have a whole number and a fraction and I just want the fraction bit, modulo 1 gets it for me, and then I use that to set the opacity directly. Now, that's just that meter number 2. I have another meter this week. I'm rather proud to introduce the cleverly titled meter number 4. It comes after meter number 3, so it must be number 4. What is it? Well, it's an LED bank. It was one of those rectangular banks of LEDs you can get with 10 LEDs and 20 little legs underneath. And I've made one of those. They're multicolor, so the first 3 in the bank are going to be green, no blue. The second bunch of them, the next 4 will be green, and then the final 3 will be red. So that's 3, 4, 3, blue, green, red. The idea being that that could be some sort of thermometer on its own if all we had was LEDs. There's no scale on it, so there's nothing as 0. It's based on how many LEDs I need to light up, which is all the scaling stuff. So if I have, I scale it to basically be 10. So if whether it's 0 to 100 or 50 to 80, it gets scaled into 10 LEDs, and then I work through those LEDs one at a time. And if a LED needs to be on, well, if it's one of the first 3, it's on blue, and if it's one of the second bunch of 4 LEDs, it's on green, and if it's the remaining 3, it's on red. I work out also LEDs can be partially on, so if you're imagining 5.5, 5 LEDs would be on, that would be 3 blues, 2 greens, and then the third green LED would be half on, and that's worked out in this section here. And what I'm doing here is, what I found was, if you try to light one of these LEDs at less than a quarter opacity, it doesn't actually look so well. So I've just decided that if it's if the fraction is less than a quarter, I just turn the LED off, which sort of goes well with electronics. It wouldn't light anyway. But anyway, if it's greater than a quarter, it comes on at whatever that proportion happens to be, and there's your modulo 1 maths again, getting the fraction of what I want the light of this LED. So without further ado, let me show you my LEDs. So here we go into my demo, and if I look at it myself, there we have it. So what do we have here? Well, there's the LEDs, the 3 discrete LEDs, and this is showing green because the temperature's just right for rain. Sitting in my own dining room, I would like to think it is. Here's the other LED style, You see we're up to about halfway on this particular scale, which happens to start, well, this is representing the same as the thermometer, so we know it's between -10 and 60, if I can read that, 60 or 70, something like that. Either way, it's about halfway up, so we've got about half the leads lit, give or take a fraction of opacity. There's my nice round meter again, all nicely fixed, and we can see that the temperature there's a bit of discrepancy between the DHT11 and the DHT22. I've been finding that a lot, actually. I also find the DHT22 is the far more accurate one. So if I was going to trust any of them, it would be the one on the right hand side at the moment. Anyway, there are my meters, and if I show you the detail on them, turn it round, you see I've got my bases, and I've even got the legs coming through the back if I wanted to connect to them to something else. But there we go, that's what it's all about. And that's me done for this week. Catch you next week. Bye bye.